Hello everyone, welcome back to my channel. This is a video on DevOps engineer interview questions part 4. So let's start. Question number 1, what is the OSI model and why is it important? The answer is the OSI model, which stands for Open Systems Interconnection Model, is a framework that standardizes how different networking protocols work together in 7 layers. These layers are physical, data link, network, transport, session, presentation and application. For physical, it deals with the physical connection like cables and hardware. For data link, it manages the data transfer between devices on the same network. For network, it handles routing and addresses. For transport, it ensures reliable data transfer. For sessions, it manages sessions or connections between apps. For presentation, it formats and encrypts data for the application layer. For application, it provides network services directly to applications like HTTP or FTP. Now, why it's important for DevOps? The OSI model helps DevOps engineers troubleshoot network issues by pinpointing exactly where the problem lies. For example, it lies in the transport or the application layer. It provides a structured approach to understanding how different components of a network communicate, helping you optimize automation and deployment pipelines. In short, the OSI model is crucial for managing and debugging network-related issues in a DevOps environment, where seamless communication between systems is the key to smooth operations and efficient deployments. Question number 2, explain the difference between TCP and UDP. TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. These are the two protocols used for sending data over the network, but they work in different ways. TCP is reliable and connection-oriented. It ensures data is delivered in order and without errors by using checks and acknowledgements. If data is lost, it will be retransmitted. It's like sending a package and confirming it's received. For example, HTTP and FTP. UDP is faster but unreliable. It sends data without confirming receipt or ensuring order. It's like sending a message without expecting a reply. It's useful when speed is more important than reliability. For example, DNS streaming. Why it matters for DevOps? TCP is ideal for apps where data integrity is critical, and UDP is better for real-time applications where speed matters more than perfect accuracy. Understanding the difference between TCP and UDP helps you optimize network performance based on the specific needs of the application. The next question, what are security groups in AWS? Security groups in AWS act like virtual firewalls for your EC2 instances. They control the inbound and the outbound traffic to your instances based on rules you define. Each rule specifies allowed traffic by protocol, port number, and source or destination IP addresses. Key points. Stateful. If you allow inbound traffic on a specific port, the response traffic is automatically allowed regardless of outbound rules. Instance specific. You can assign multiple security groups to an instance, allowing granular control. Now, why it's important for DevOps? Security groups are essential for securing infrastructure, ensuring only trusted traffic can access your instances. As a DevOps engineer, you will configure them to limit access based on rules or environments. In short, security groups protect your cloud resources by controlling traffic and enforcing access rules at the instance level. Next question, how do you implement network segmentation in a cloud environment? The answer is, network segmentation in a cloud environment involves dividing your network into smaller, isolated sections to improve security, performance, and manageability. Here is how you can implement it. First is virtual private cloud. In AWS, use VPCs to create isolated networks. You can have multiple VPCs for different environments to keep them separate. Second is subnets. Within a VPC, create subnets to segment your network further. For example, place public facing resources in public subnets and private resources in private subnets. Third is security groups and network ACLs. Use security groups to control traffic at the instance level and network ACLs to control traffic at the subnet level. These tools restrict access between the segments. Fourth is route tables. Configure route tables to control traffic flow between subnets and between VPCs. You can restrict communication between segments or allow it based on security policies. Fifth is VPNs or peering. For cross VPC or hybrid cloud setups, use VPNs or VPC peering to securely connect segments while maintaining isolation. Now, why it matters for DevOps? Network segmentation is crucial for limiting attack surfaces, ensuring that sensitive data and critical infrastructure are isolated from less secure areas. It also helps with better traffic management and scaling. In short, network segmentation helps your cloud infrastructure remain secure, organized, and optimized for performance. Next question, describe the best practices for securing a CI/CD pipeline. The answer is, to secure a CI/CD pipeline, follow these best practices. First is use secrets management. Store sensitive data like API keys in secure vaults and not in the code. Second is limit access. Implement least privilege access for users and services interacting with the pipeline. Third is automate the code scanning. Use static and dynamic analysis tools to detect vulnerabilities early. Fourth is use secure environments. Ensure your CI/CD environments are isolated and well configured. Fifth is enable encryption. Encrypt communication between systems and sensitive data at rest. Sixth is regularly update dependencies. Keep libraries and tools up to date to prevent known vulnerabilities. Seventh is audit and monitor. Continuously monitor the pipeline activities and log all actions for review. By integrating these practices, you ensure that the pipeline is efficient, secure, and reliable. The next question, what scripting languages are you comfortable with? The answer is, you can say, I am comfortable with several scripting languages commonly used in DevOps, including Bash, which is used for automating tasks and managing Linux environments. Second is Python, used for more complex automation and integration tasks. Third is Groovy, used in Jenkins for pipeline scripting. Fourth is YML or JSON for configuration management in tools like Kubernetes and Ansible. These languages help me automate workflows, manage infrastructure, and streamline deployments effectively. If you have used any other scripting languages that you are comfortable with, you can answer them accordingly. Question number 7. How do you automate the deployment of applications? The answer is, to automate the deployment of applications, I follow these steps. First is version control. Store the application code in Git repositories for easy tracking. Second is CI/CD pipeline. Set up pipelines using tools like Jenkins, GitLab CI, or Circle CI to automate build, test, and deploy processes. Third is infrastructure as a code. Use tools like Terraform or Ansible to automate the provisioning and configuration of infrastructure. Fourth is containerization. Use Docker to package the applications and Kubernetes for automated orchestration and scaling. Fifth is monitoring and rollbacks. Implement monitoring with tools like Prometheus and automatic rollback strategies to ensure smooth deployments. This approach ensures fast, consistent, and reliable application deployments across environments. Question number 8. Explain the importance of writing reusable scripts. The answer is, writing reusable scripts is important because it saves time and reduces errors. By creating modular, well-structured scripts, you can automate common tasks across different projects without rewriting code each time. This improves consistency, scalability, and maintenance, allowing teams to focus on more complex tasks instead of reinventing the wheel. Reusable scripts also make collaboration easier and ensure best practices are followed across the team. Question number 9. What is the role of cron jobs in automation? Answer is, cron jobs are essential for automation because they allow you to schedule and run tasks at specified time or intervals automatically. In DevOps, cron jobs can be used to automate routine tasks like backups, system maintenance, log rotation, or regular deployments, ensuring they happen without manual intervention. This helps improve efficiency, reduce human error, and ensure critical tasks are consistently executed. The next question, describe a scenario where you automated a manual process. The answer to this is, in my previous role, I automated the process of deploying application updates to multiple servers. Previously, this was done manually by SSI into each server, pulling the latest code and restarting services. I created a script using Ansible to automate the entire process. The script would pull the latest code, update configurations, and restart services across all servers with a single command. This reduced deployment time from hours to minutes, minimized human errors, and ensured consistency across all environments. Next question, what agile methodologies have you worked with? You can answer this question as I have worked with Scrum and Kanban methodologies. In Scrum, I participated in sprint planning, daily stand-ups, and retrospective to ensure smooth collaboration between development and operations team. With Kanban, I focused on continuous delivery and managed workflows to improve efficiency. Both methodologies helped me adapt quickly, prioritize tasks effectively, and deliver faster and more reliable deployments. Next question, how do you handle conflict in a team setting? You can answer this as I handle conflict by first listening to all the perspectives and understanding the root cause of the issue. I focus on clear, open communication to find common ground and encourage collaboration. In a DevOps setting, I ensure everyone's priorities are aligned with the team goals and the bigger picture. If needed, I facilitate compromise or suggest solutions that benefit both development and the operations team, fostering a cooperative environment to resolve conflicts efficiently. The next question, describe your experience with tools like Jira or Trello. You can answer this question as I have experience using Jira and Trello to manage tasks, track of project progress, and collaborate with teams. In Jira, I have created and managed user stories, tasks, and sprints, ensuring smooth workflows and timely delivery. With Trello, I have used boards to visualize and prioritize tasks for better team alignment. Both tools have helped me stay organized, improve communication, and keep track of both development and operational tasks in a DevOps environment. Question number 14. What is DevOps and how does it differ from traditional software development? The answer is DevOps is a culture and set of practices that bring together development and operations team to collaborate more closely. The goal is to automate and streamline the software development lifecycle from coding to deployment, making it faster and more efficient. Unlike traditional software development, where teams often work in silos, separating dev, testing, and ops, DevOps emphasizes continuous integration, continuous delivery, and shared responsibilities. This leads to faster releases, better quality, and quicker resolution of issues. Question number 15. How do you encourage collaboration between development and operations team? You can answer this question as I encourage collaboration by fostering open communication and shared goals between development and operations team. I promote regular cross-team meetings like daily stand-ups to discuss progress and challenges. I also emphasize the importance of using common tools like Jira and Git and practices like CI/CD that both teams can contribute to. By breaking down silos and encouraging knowledge sharing, I help both the teams work together smoothly to deliver high quality software faster.